My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 184. In this lecture, we will try to understand hypothesis testing in linear regression. What is hypothesis testing? There are two types of hypothesis, as I told you in previous classes. H0, that is my null hypothesis. HA or H1 is alternative hypothesis. Let me assume this is my regression equation beta naught plus beta 1x. This is, let me say, this is related to population. For example, if it is sample, I can write y equal to beta naught b naught plus b1x. This is related to sample, isn't it? Yes. My assumption in null hypothesis is beta 1 equal to 0. What is my beta 1 equal to 0? Let me substitute y equal to beta naught plus beta 1x. What is my beta 1? Assumption 0. 0 into x means 0. Therefore, what will I get? I will get y equal to beta naught. Y equal to constant means a line parallel to x-axis like this. Just take any x value, you will get same y value. What does it mean? There is no relation between x and y. Our alternative hypothesis says HA is beta 1 not equal to 0. What is my test statistic here? T equal to B1 minus beta 1 by SB1. Anyway, we know this is our sample model, y equal to b naught plus b1x. We know what is b1. We know what is beta 1. Our assumed value of beta 1 is 0. SB1, what is my SB1? I can say SB1 is the standard error. What is this? This is standard error, isn't it? Anyway, I will standard error for coefficient of b. For coefficient of B1. Anyway, I will discuss this in Jupyter. I already discussed in lecture number 179. I will recall that after a few seconds. Just let me proceed further. What is my formula? As I told you, this formula is T equal to B1 minus beta 1 by SB1. This beta 1 anyway, we are assuming 0. If I keep 0, what will I get? B1 minus 0 by SB1. That's what it says, B1 by SB1. This is my test statistic. As I told you, what is the meaning of beta 1 equal to 0? That means there is no relation between x and y. That's what it says. There is no relation. If beta 1 equal 0, I already discussed. You will get a straight line, isn't it? Therefore, there is no relation in this case. Therefore, what is the meaning of beta 1 equal to 0? That means there is no relation between x and y. When you plot the data, in this case, the null hypothesis is not rejected. It is accepted. Beta 1 equal to 0 means null hypothesis is accepted. That is no relation between x and y. When you plot data, as I told you in previous slide itself, you will get a straight line, isn't it? If beta 1 is not equal to 0, what happens? There is some relation between, just say, there is some relation between x and y. In this case, the null hypothesis is rejected in which beta 1 is not equal to 0, isn't it? What it says, let me formulate this one in systematic manner. What is the rejection rule? Rejection rule is reject H0 if p value is less than or equal to alpha or mod t is greater than t alpha by 2. What is my t alpha by 2? It is a t distribution with n minus 2 degrees of freedom. How will it be? Just see, let me formulate this in systematic manner. What it says, determine the hypothesis. As I told you, my null hypothesis is beta 1 equal to 0. Alternative hypothesis is beta 1 not equal to 0. My level of significance alpha is 0.05. That is, I can say it is 5%. As I told you, my test statistic is T equal to B1 by SB1. Reject H0 if p value is less than or equal to alpha. What is my alpha? 0.05. Or mod t is greater than t alpha by 2 with 3 degrees of freedom. How you are getting this 3 degrees of freedom? As I told you, 3 degrees of freedom, how many? Just I request you to refer this lecture number 179, in which I discussed this problem. How many observations are there? There are 5 observations. N minus 2 degrees of freedom. Just go to previous slide. Just see what it says. N minus 2 degrees of freedom. What is my n value? N is 5. Therefore 5 minus 2. N minus 2 means 3 degrees of freedom. It's as it is two-tailed test. Alternative hypothesis, you have not equal to symbol means two-tailed test. Your alpha by 2 you have to check. Alpha by 2 means 5%, that is 0.05 by 2. That anyway I will check after few minutes. Just go to that t distribution table where you can find this 3.182. After few seconds I will discuss. Just let me proceed further. Compute the value of the test statistic. I already explained how to calculate value of test statistics. That is t equal to b1 minus beta 1 by SB1. This is my t value, and determine whether to reject or accept. What is the rule? Rejection rule. Reject H0 if p value is less than or equal to alpha, isn't it? Otherwise I can say mod t, or there is another way, mod t is greater than t alpha by 2 with how many degrees of freedom? With n minus 2 degrees of freedom. We will try to understand how will it be, how one can do it. Just say this one. Yes, this is the result. I kindly request you to go through lecture number 179. In this lecture I discussed this output. Now we will try to understand this output. Now what you have to do, as I told you, what is my t statistic? My t statistic is t equal to b1 minus beta 1 by SB1. Anyway, in null hypothesis we were assuming that beta 1 is 0, that is b1 by SB1. What is my b1 value? Just see, b1 is y equal to I can say b1 is, it is related to what? TV ads. This also I discussed, this coefficient. Just see, this is the coefficient 5 by SB1. What is SB1? Standard error. This TV ads is which variable? Independent variable, isn't it? Therefore I can say what is standard error for this one? 1.08. If you calculate this t value, you will get 4.63. That is approximately 4.629. This is my t value. Just see this one. 4.629 means I can write it as 4.63. This is my t value. This t value you have to compare with what? You have to compare this t value as it is two-tailed test. How do you know it is two-tailed test? In alternative hypothesis we have not equal to symbol. In that case I need alpha by 2. Alpha, what is my alpha? 0.05, 5% by 2. Alpha by 2 means 0.05 means it must be 0.025. At how many degrees of freedom? N minus 2 degrees of freedom. How many observations? Just see, total observations in this particular problem. Just see, number of observations are 3. Therefore n minus 2 degrees of freedom means 5 minus 2. Just refer lecture number 179. I discussed this problem in lecture number 179. 5 minus 2 means 3 degrees of freedom. At 0.025 level of significance, at 3 degrees of freedom I must see. Just see, 0.025. Let me check this one. This is 0.025. This is 3 degrees of freedom. What is that value? Just see, that is 3.182. That's what it says. That is 3.182. If you want, just you can check it out again. It is at 3 degrees of freedom. How you are getting 3? Total n minus 2 degrees of freedom. N means 5. 5 minus 2 means 3 degrees of freedom. Alpha by 2. Why alpha by 2? It is two-tailed test. Alpha is 0.05 by 2 means 0.0. This is t distribution table. From any standard book you can get this particular table. Therefore now you have got two values. What does it mean? What is my test statistic value, my test statistic value, that is 4.63, my table value, what is my table value? 3.182, isn't it? Mod t is greater than t of alpha by 2 at n minus 2 degrees of freedom. That is 4.63 is greater than 3.182. In that case, what you have to do? You have to reject. Which one you have to reject? You have to reject H0. You must reject H0, isn't it? There is another approach, I can say, that is p-value approach. What is my p-value for t-test? My p-value for TV ads, isn't it? This is independent variable, that is 0.09. That is p equal to 0.019. My alpha, my assumed alpha is 0.05. P-value is 0.019 is less than alpha, that is 0.05. P is less than alpha. In that case, you must reject H0. Therefore, I am rejecting H0. What is my H0? Beta 1 equals 0. That we are rejecting H0. According to p-value approach also, we are rejecting H0. According to t-test statistic also, we are rejecting H0. Now, we will try to understand same problem with the help of confidence interval. If you want, you can go back and check how can I calculate confidence interval. We can use 95% confidence interval. Means 5% level of significance, means that is 95% confidence interval. Next, we can use 95% confidence interval for beta 1 to test the hypothesis just used in the test. Now, with H0 is rejected if hypothesized value of beta 1. What is my hypothesized value of beta 1? That is 0. Is not included in the confidence interval. What is our, I can say, our assumed value of beta 1 is equal to 0. In the confidence interval, the 0, if 0 is appearing, we have to accept null hypothesis. If beta 1 is in confidence interval, you must accept null hypothesis. If beta 1 is not in confidence interval, you must reject null hypothesis, isn't it? That's the confidence interval procedure. Anyway, what is beta 1 assumed hypothesis value? 0. Therefore, if 0 is in confidence interval, I must accept null hypothesis. If 0 is not in confidence interval, I must reject null hypothesis. How can I calculate confidence interval? This is the formula B1 plus or minus T alpha by 2 into SB1. This I already discussed. This we will try to calculate after few seconds. Just see, reject H0. What is rejection rule? Reject H0 means null hypothesis if 0 is not included in the confidence interval. For what? For beta 1. 95% confidence interval. How to construct? In previous slide we have seen that formula. According to formula, first you have to calculate 95% confidence interval. What is your conclusion? If 0 is in confidence interval, then I can say reject H0. If 0 is in confidence interval, accept H0. If 0 is not in confidence interval, reject H0. That is the procedure. How can I do it? Just we will try to understand. Just let me go to this one. How can I calculate 95% confidence interval? Just see, what is my formula for calculating 95% confidence interval? B1 plus or minus T alpha by 2 into SB1. What is my B1 value? My B1 value, that is TV ads, that is independent variable, that is B1 is 5. plus or minus T alpha by 2. Just I have shown 3.182, that is table value. Just see here. Just 1 second. This is 3.182. From table I have shown, isn't it? That is 3.182. Just let me, yes. That is T alpha by 2. What is my T alpha by 2? That is 3.182. What is my SB1 value? SB1 means standard error. That is 1.080. Just if you calculate this one, what will I get? 5 plus or minus 3.44. If you subtract, you will get 1.56. This is lower limit, and if you add, you will get 8.44. This is upper limit. Means in between these limits, in this interval, what is your beta 1 value? 0. Hypothesis beta 1 value. Is it in between these two limits? No. If it is not there, what you have to do? Reject H0. Means we discussed, this is confidence interval approach. I already discussed T value approach. In that one, I used T statistic. Even I discussed in T value approach, I used P value also we used. Now this is confidence interval approach. In this confidence, according to this confidence interval approach also, we are rejecting null hypothesis H0. Now we will try to understand F test. What is my F test? What does it mean? Just if you, I can say like this. In our previous lectures, we used T test. Sometimes what will happen if number of independent variables are more than 2? For example, if there are 5 independent variables, 5 means it's more than 2. If there are 5 independent variables, then you have to do 5 individual T tests. As we discussed, whenever you are comparing more than 2 independent variables, you have to go for ANOVA, that is F test. I can say an ANOVA is a specific type of procedure that produces an F statistic because it tests the ratio between symmetric variance and error variance. Here also, whenever the number of independent variables are more, you can go for F test. I can say this is generic method for testing. F test is generic method for testing for beta 1 equal to 0. Let me say what is my F value, MSR by MSE. What is this MSR? We already discussed about this MSR and MSE in our previous lectures. MSR means, I can say, mean square due to regression. What is my MSE? Mean square due to error. This is my formula, isn't it? It's something like, even in ANOVA also, in ANOVA, what we are trying to do, this is, we were saying something like that, MS treatment, isn't it? MS treatment by MSE. This we discussed for ANOVA, isn't it? Just go back and check your ANOVA class so that you will get an idea. I already discussed about ANOVA in my previous lectures. I can say MSR is equal to SSR by degrees of freedom. This SSR I already discussed. MSE is nothing but SSE by, I can say, degrees of freedom. Anyway, we will try to understand your with the Python. Already I discussed this particular code. First, let me state what is my rejection rule. My rejection rule is reject H0 if p value is less than or equal to alpha, or f is greater than or equal to f alpha. This is a systematic procedure. Let me formulate in systematic manner. Just see, H0 beta 1 is equal to 0, alternative hypothesis, beta 1 not equal to 0, alpha 0.05, level of significance, test statistics, MSR by MSE. Reject H naught if P value is less than or equal to alpha. This is the rule. RF is greater than or equal to 10.13. We will discuss how you are getting this 10.13. Just let me go to that particular output again and again. To get this output, just refer lecture 179. In that lecture I discussed, we have shown this output. Now we will try to understand our F statistic. What is my F statistic? I already discussed R squared, isn't it? F statistics. What is your F statistic value, or what you are getting? 21.43. Anyway, let me say like this. Yes, F test. What is F test? What is F test P value? This is F test P value. P equal to 0.0190. Reject H naught. Same rule. Reject H naught if P is less than or equal to alpha. What is my P? 0.019. What is my alpha? 0.05. Therefore, it's true. Therefore, 0.019 is less than 0.05. Therefore, reject H naught according to P value of F test, isn't it? Now what is my calculated value of F statistic? Just see, this is 21.43. How will you get MSR by MSE? We discussed that formula. Anyway, this is my F statistics, 21.43. Now, what I have to calculate? I need tabulated value. How will I get? F follows F distribution with K numerator degrees of freedom. K is numerator degrees of freedom, and N minus K minus 1 denominator degrees of freedom, where K is number of independent variables. What is K? Number of independent variables. How many independent variables do we have? Independent variables. In lecture number 179, I discussed this problem. TV ads is independent variable, isn't it? Therefore, K equal to 1. Therefore, numerator is 1. Denominator, how many observations are there? Total 5 observations. Number of independent variables is 1. 5 minus 1, that is 1 by 3. Means 1 is related to degrees of freedom of numerator. 3 is related to degrees of freedom of denominator. Just just go to this particular table and check this value. This is F distribution table, where you can find in any standard textbook. What is numerator degrees of freedom? Numerator degrees of freedom is 1. Denominator degrees of freedom is 3. This value, F table value. This is F, which value? Table value. At what level of significance? 0.05. That is 10.13. Isn't it? That is 10.13. Just remember, that is 10.13. Let me say that value, table value, I must 10.13. Therefore, what can I say? F is greater than or equal 10.13. This is table value. You must always remember. Now, what is calculated F statistic value? 21.43. If your calculated value is greater than table value, then I can say reject H naught, reject null hypothesis, isn't it? We discussed different approaches. Which approaches we discussed? We discussed t-value approach. In t-value, we calculated test statistic, and p with the help of p-value also we concluded reject H naught. We discussed confidence interval approach, reject H naught. We discussed F statistics approach, we reject H naught. All these end result is same. There is another one. There is something like AIC value. This is AIC and BIC values. What is this AIC and BIC values? The AIC means what? Acai K. Let me write. AIC means Acai K. AKI-K. Acai K information criterion. That is AIC. The Acai K information criterion is an estimator of in-sample prediction error, and thereby it gives relative quality of statistical models for given set of data. AIC estimate, I can say like this, AIC estimates the relative amount of information lost. This is important. What AIC estimates? Relative, let me write, relative amount of information lost. That is AIC indicates information lost. Means if you have small AIC value, small information is lost. Therefore, it is always advisable to have small AIC value, isn't it? Let me repeat. AIC estimates the relative amount of information lost by a given model. The less information a model loses, the higher the quality of the model. I can say AIC is a single number that can be used to determine which of multiple models is most likely to be the best model for a given data set. AIC scores are only useful in comparison with other AIC scores for same data set. A lower AIC score is better. I can say there is a data set. For that data set, we have model 1, model 2, model 3. I must choose best model. I have to calculate AIC value for this one, AIC value for this one, AIC value for this one. If means which value is small value. If I say model 1 has got less value compared to model 2 and model 3, I can say model 1 is the best model. That's a concept anybody can understand. In similar to AIC, we have another one that is known as BIC. Bayesian Information Criterion is a criterion for model selection among finite set of models. The model with the lowest BIC is preferred. AIC and BIC are widely used model selection criteria. BIC is consistent where AIC is not so. BIC is more tolerant when compared to AIC. AIC is better in situations when a false negative finding would be considered more misleading than false positive. And BIC is better in situations where a false positive is as misleading as or more misleading than false negative. Even this DF residuals, what does it mean? How can I find this DF residuals? It is used in, what is that number 3? We used in F test, isn't it? What is the formula for DF? DF means degrees of freedom. This is DF residuals. Degrees of freedom residuals formula is n minus k minus 1. N means what? Number of observations. How many observations? In that problem there were 5 observations. K is independent variables. 5 minus 2, that is 3. That is DF DF residuals, isn't it? DF model indicates number of independent variables. Just see this DF model. This is 1. How many independent variables? We have TVADs, only 1 independent variable. In future classes, I will discuss about this adjusted R-square value. I already discussed about R-square value. I will discuss about other parameters also. Just time being, just go through this lecture. This lecture is very important. If you have any difficulty, just keep a comment. Thank you very much.